This was one of the most daring missions ever undertaken, an Israeli operation that infiltrated deep into the heart of Iran. The ground operations have been meticulously planned once in advance and unfolded in several strategic stages. The first stage involved launching spike missiles to eliminate Iran's anti-air defense systems. The second stage saw the secret establishment of drone bases within Iranian territory. These bases were positioned to target the Formidable S-300 air defense system. In the third stage, Israel launched airstrikes using bunker buster bombs aimed at key nuclear facilities, namely Fordow, Natanz, and Isfahan. These nuclear sites are heavily fortified, buried deep underground, with bunkers estimated to be as tall as 6 stories. While these strikes caused some damage to the surrounding infrastructure, they did little to harm the deeply buried core facilities. To breach such depths, Israel would require the US-built GBU-57, a massive ordnance capable of penetrating over 8 stories underground, delivered by the stealthy B-2 Spirit bomber. More details all in the video ahead. What set Operation Rising Lion apart from Israel's previous strikes, whether in Syria, Iraq, or even during clandestine missions inside Iran, was the unprecedented fusion of on-the-ground infiltration, domestic infiltration, and high-precision aerial strikes. This wasn't just another isolated attack, it was a meticulously coordinated assault aimed at dismantling Iran's military infrastructure from within, delivered in a single synchronized blow. For months leading up to the operation, Israeli operatives were embedded deep inside Iranian territory. Working in absolute secrecy, Mossad agents smuggled precision-guided missile systems into the country. Among them were Rafale Spike NLOS, non-line-of-sight missiles cleverly mounted on mobile platforms and hidden inside civilian vehicles. These launchers were strategically placed near critical Iranian military assets, including surface-to-air missile batteries and mobile launchers scattered around Tehran. Hidden in plain sight, they sat silently in inconspicuous locations, waiting for the signal. When the aerial assault finally began, those concealed launchers sprang to life. Remotely activated, the missiles fired with surgical precision, striking multiple air defense sites before Iran's military could even react. But that was just one layer of the operation. Simultaneously, Israeli spy agency had constructed a secret drone base inside Iran, an effort that mirrored battlefield tactics seen in places like Ukraine, but taken to an entirely new level of sophistication and secrecy. The drones had been smuggled into the country piece by piece, assembled quietly over several months. The fact that such a facility could be built and operated undetected so close to Tehran revealed the extraordinary reach and meticulous planning behind the mission. From this secret base, waves of small UAVs and larger explosive-laden quadcopters were launched. These drones played distinct roles. FPV drones were the first to strike, hurtling toward air defense systems in suicide attacks, while the quadcopters followed up with targeted blasts to finish the job. Together, they neutralized critical SAM sites, including advanced S-300 batteries, effectively blinding Iran's air defense grid. Although Israel has been bombarding Iran's nuclear sites since June 13, 2025, it's worth taking a closer look at why these strikes continue to happen again and again. The answer lies deep underground, literally. These nuclear facilities aren't just hidden, they're buried under layers of reinforced concrete and soil designed specifically to withstand most conventional attacks. Israel has been using its own bunker buster bombs, but according to the International Atomic Energy Agency, these weapons have not been able to fully penetrate Iran's most fortified underground nuclear sites. That's why Israel keeps striking the same targets repeatedly. The aim is to chip away at the defenses layer by layer. If Israel had used the more advanced American-made bunker buster bombs, capable of deeper penetration, the outcome might have been more decisive, possibly damaging or even destroying the underground uranium enrichment facilities in one go. We'll return to those American munitions in a moment, but first, let's look at what Israel has been targeting and why. The Israeli Defense Forces' primary goal is to cripple Iran's nuclear program by hitting its most critical enrichment sites, specifically Fordow, Natanz, and Isfahan. Take Natanz, for example. This facility includes 6 above-ground buildings and 3 underground structures. two of which are large enough to hold 50,000 centrifuges, according to the Nuclear Threat Initiative. After Israel's recent bombardment of the site, early assessments suggest the strikes were highly effective. They went far beyond surface damage, knocking out power on the lower levels where the centrifuges are housed. The above-ground section of the pilot fuel enrichment plant was also destroyed. This plant, operational since 2003, had been enriching uranium up to 60% purity. For context, weapons-grade uranium is enriched to 90%, so this site was dangerously close to that threshold. Now consider Fordow. Unlike Natanz, Fordow is located deep underground and protected by extensive fortifications. Israel targeted it with advanced bunker-busting munitions, but the results were far less conclusive. Their bombs struggled to break through the dense shielding. The damage was minimal, despite the repeated strikes. In fact, Israeli jets dropped these munitions multiple times on Fordow, triggering a localized earthquake measuring 2.5 on the Richter scale, an indication of the shear force being used. This site remains a major challenge, protected by both its geography and Iran's sophisticated missile shield. The reason Israel keeps returning to these same targets isn't just to make a statement. It's because cracking open Iran's nuclear program is a lot harder than hitting a target once and moving on. This is why Israel needs the US to deliver the GBU-57 bunker buster bomb to crack open Fordow nuclear site. First, we have the BLU-109, also pronounced blue. It is a 2,000-pound bomb developed in the 1970s. This weapon is capable of penetrating approximately 1.8 meters or about 5 feet of reinforced concrete. Next, we move to what Israel is using, the GBU-28 fitted with laser guidance at the front of the bomb. This bomb can penetrate to a depth of nearly 6 meters, equivalent to roughly 20 feet, which is as tall as a 2-story building. However, neither of these compares to the massive capabilities of the GBU-57, also known as the Massive Ordnance Penetrator. It can penetrate over 60 meters into the ground, around 200 feet. To put that in perspective, this depth is comparable to the height of a 20-story building, depending on the floor heights. These examples demonstrate the significant advancements and differences in penetration levels among these specialized weapons. This means it can penetrate Fordow nuclear site. Let's put an average human here against this weapon, which is 20.5 feet long, giving it a streamlined aerodynamic shape that is crucial for stability and precision. With a diameter of 31.5 inches and weighing an incredible 30,000 pounds, translating to approximately 14,000 kilograms, it utilizes its massive weight to generate the kinetic energy required for deep penetration. This heavy, compact design enables it to break through over 200 feet of reinforced concrete, making it one of the most effective bunker-busting munitions in the world. But the US is the only country that currently possesses this technology. To deploy such heavyweight weaponry, you need this $1 billion stealth aircraft, like the B-2 Spirit bomber featured in our recent video. That's because Iran still has a robust air defense system, and a standard aircraft could easily be detected and shot down by their radar. Step 1. The bomb deployment platform. As previously mentioned, a B-2 stealth bomber flies at a very high altitude. When the aircraft reaches the designated location and the conditions are optimal, it releases the weapon. The bomb is designed for precision, and the deployment height plays a crucial role in its trajectory and effectiveness. Then step 2 comes the targeting precision. The bomb is outfitted with advanced guidance technology, including GPS and inertial navigation systems, which are military-grade satellites. Then comes step 3, that is adjusting the trajectory. The guidance information and data is then transmitted to the bomb's 4-lattice motors fins located at the rear. These fins can move and adjust in real time, allowing the bomb to correct its course as it descends under the force of gravity. These adjustments are essential because the weapon does not have thrusters to change its trajectory. Instead, it relies on the movement of these fins and a high-altitude drop to control its flight path. This is why the bomb must be deployed from a very high altitude so it has enough time and distance to adjust its trajectory accurately. Here comes the most difficult part, that is step 4, impact and penetration. The bomb, known as the Massive Ordnance Penetrator, weighs approximately 30,000 pounds, which is around 14,000 kilograms. When it reaches its target, it strikes with immense force, designed to penetrate deep into hardened structures, such as bunkers. The energy upon impact allows the bomb to bury itself over 200 feet into reinforced concrete, ensuring it delivers its payload precisely where it is intended for maximum effect. Finally, Step 5 involves the tricky part of arming the weapon. It was installed with 2 SDB fuses. Double fuses are required as a backup. The first is for G-sensing and the second is the time delay fuse. Why the redesign was necessary, it was to ensure that the bomb could strike facilities buried beneath significant layers of hardened material. For this reason, the fuses are placed at the rear of the bomb to prevent them from being damaged. Once the time delay or the G-sensing fuse reaches its destination, it can blow up, creating a mini earthquake that can bury bunkers and 20-story buildings inside them. As Iran air defense system were neutralized. This is how Israel assassinate the nuclear scientists and general using laser guidance and bunker buster bombs. The Israeli Air Force also deploys non-stealth aircraft like the F-15, armed with a range of munitions to carry out precision strikes on multiple locations. The tip of the spear would have been the bunker buster bomb that can penetrate through this 6-story building. It can level out several blocks with just a couple of ammunitions. This is the bunker buster bomb. It has a laser sensor at the front, and just behind that are adjustable fins. In the midsection, there is a warhead that weighs approximately 650 pounds containing tritonal explosive. This is a mixture of 80% TNT and 20% aluminum powder. Let's take a look at how this works. Step 1. First, a laser is used to illuminate the target, or GPS guidance is already assigned to it. Step 2. An F-15 jet flies near the illuminated target and the bomb is released. Step 3. Once the bomb is dropped, the guidance system at the front connects with the tail and fins. This enables the bomb to make precise adjustments, guiding it accurately to its target. Step 4. As mentioned, this is a bunker buster bomb designed to penetrate around 6 meters of reinforced concrete bunkers and can travel up to 100 feet of soft ground or buildings. Step 5. In the past, the GBU-28 has been equipped with a delay fuse like this one, allowing it to detonate after penetrating its target, rather than exploding on impact. The bomb contains 700 pounds of TNT, which generates a blast radius of several hundred meters, quite significant for a bomb of this size. We make original animations from scratch with just 3 animators, so please subscribe, like, and comment for more videos.